Good morning, everyone. I'm Avi Tavanian.
Good morning, Phil Schiller, and this is the Avi and Phil Show.
We're here to entertain you for the next afternoon as best we can.
As you know, recently, as of yesterday, we made an announcement with macOS 10 that we're all pretty excited about, that it will now become the default boot operating system on new machines we ship starting this month. And with that news and just the momentum we've had building over the last 9 months with macOS 10, there was a request from some people for us to come here to the show and get a little more detailed, talk a little bit more about the technologies in macOS 10. So that's why we've created this session, and very thankful to the good people at IDG to allow us to quickly add this section into the show so that we could talk to you about some of the power in macOS 10 and some of the technologies that make us confident on why we're making this the platform for the next decade for the Macintosh. Now, some of you, if you're brand new to the idea of macOS 10, you haven't seen it, you haven't tried it out, this is not a primer. This is not macOS 10 101. If you want that, we have that in the booth. It's running on and off daily, and you can go do that. This was to get a little deeper than that, a little more technical than that.
Yeah, so Phil says that means that we're going to be speaking geek. I'm not quite sure what he means by that. Seems pretty normal stuff to me. I guess what it means is we're going to go into a little bit more detail than we otherwise might at a venue like this. And what we're really going to try to do is show you some things that you otherwise may have never seen or may just not know, even though it exists in macOS 10 and for macOS 10.
Great. So some of the things we're going to cover in the roughly 1 hour we have with you, between you and lunch, I'm guessing, is we're going to talk a bit about the core operating system. What's the heart underneath the engine of macOS 10? We'll talk about the media layer and a number of the media technologies inside the operating system. Talk about something that's very important nowadays, security, and how that relates to 10. We'll talk about, of course, Aqua, this great new user interface that it brings to the Macintosh. We'll talk about a number of the programming environments and the applications that means we're all going to get on macOS 10. So Cocoa and Unix and Java and even AppleScript, which is itself becoming a programming environment to make very powerful applications. So to begin with, let's kick off right away with the core of the operating system, that heart that beats at the center of macOS 10 and delivers so many amazing technologies to make this the stable, robust platform for the future.
Okay, and let's start with the very lowest level piece of software in the system. That's the kernel. The kernel is that layer of software that separates the bare hardware from everything on top that does the visual user interface and all the application layers. Now, what I find interesting about the kernel in macOS 10 is although no one ever really sees it, they get huge benefits from all the new technology we've gotten here. In fact, arguably, if you look at all the requests that we've had from our customers about things to do to make the macOS better, the kernel is responsible for a large number of those that have very high impact. For example, in the area of memory protection, and virtual memory. These are two important new technologies that exist in macOS 10 that make the whole experience much better. You don't have apps that crash, and you can have an app that crashes, but if it crashes, it doesn't take down the system or compromise any other process in any other way. And with virtual memory, every application can use as much memory as it really wants to. Way more than you have in terms of physical memory in your computer, because the system virtualizes it for every application. For managing the CPU, or in the case of a dual CPU system, multiple CPUs, the system has very advanced technologies for dealing with how to partition who gets to use which processor and when from an application perspective, which means we get great features like symmetric multiprocessing, really making use of two CPUs when there's two CPUs in your box. And we get applications that can become easily multi-threaded and use multitasking to make their experience overall, as well as the experience of the system overall, much more smooth. Now, sometimes when you have features like this in an OS, you have to give up some things. But what we've been careful to do is to make sure we also have good real-time support so that even though the OS now can control which process runs and where, if an application is really important and needs to get something time-critical done, it can indicate that to the kernel, and the kernel can make sure it gets scheduled appropriately using real-time processing. So let's show a demo of some of this. Okay, what I'd like to do first is, see this little gadget right here? This is something that we call the CPU monitor. I'm just going to leave it up running here on the right-hand side of the screen, top right for a moment. The CPU monitor is telling us how many of the cycles of each processor are being used. I have a dual processor system, so I have 2 bars, 1 bar for each processor in the system. And as you can see, right now the system is just idle, so the bars are all the way down. If I bring up a window like this and start dragging around, you see that we're starting to use CPU, as you would expect, because you don't get this kind of stuff for free. Let me just bring up a QuickTime movie and start playing that. So as you can see, we're starting to use some of each CPU to render and play this movie. We're not using all of the CPU because we don't need to. The player doesn't need to use all the CPU to play this, and so the rest is left over for other things that you might want to do. In fact, what you see going on here is we're not just using one CPU with the other one being completely idle. We're seeing the time sharing going on the CPUs because the system is automatically scheduling parts of the QuickTime player on each CPU as it sees fit. So while that's going, let me bring up something else. Bring up iTunes. And so for iTunes, we have a CD in the machine already. What I'm going to do is click import, and this will start up. We're now ripping the whole CD, and that's going on at the same time. Notice how we're using a lot more CPU cycles. We've still got a little bit left over, but again, we're spreading the load off on the 2 CPUs. In fact, the QuickTime playback is just going along fine, no hiccups, no nothing. While this is all going on, let's bring up Internet Explorer, and as you might expect, that's working fine. It's notable that everything is still very smooth. And I can even still go over here. I can put a menu over the QuickTime window, have it be rendered automatically through the transparent window there, the transparent menu, and it's all just working. Now we're really starting to use CPU here because doing that transparency and compositing everything can be expensive. But again, everything is just really smooth as silk because the scheduler's allocating everything where it needs to go. We can even really start to stress the system, go to a movie trailer on the website, and so there it is downloading, playing through IE, through the QuickTime plug-in a movie, while another QuickTime movie is playing, while we're ripping a CD. So let me just leave all this running for the moment. As you can see here, we've got really advanced symmetric multiprocessing going on. I want to focus on another really interesting feature of the system, and that's basically the memory protection that we have. Let's say for the moment that for some reason, i.e. something went wrong with it, it got hung up or locked up or something, it wasn't responding. What you can do with Mac OS X is you can just quit it directly, forcibly quitting it, and not worry about what happens to the rest of the system. So again, I just bring up the Force Quit Applications panel, and we're still ripping the CD, we're still playing the trailer. I just hit Force Quit, and bang, the application is gone. We just shot it dead, stopped its processing, but the rest of the system just keeps on going completely smoothly, no issues. In fact, this is kind of interesting. If you look at the list of applications in my window there now, what you see is that one of them listed is the Finder. This shows an extra level of robustness that the OS has. The Finder isn't even essential for the rest of the system to work. So this may seem kind of odd. Let me bring a Finder window up to show this, but there's a Finder window right there. Again, my QuickTime movie, iTunes is still going along just fine. I can click on the Finder there. In this case, it knows it's the Finder. Instead of just killing it, it'll kill it and relaunch it. And so now when I hit it, watch the Finder window just disappear. The background went away. Finder window comes back along with the background. And everything just keeps on going. No problems at all.
So I hope you see we're building an incredibly modern, robust core operating system. In addition to the kernel, some of the other key elements we wanted to mention today about the core OS, the file system. We have a file system that's something usually as a user we don't think about. It just works, it's there. But in Mac OS X, we have a dramatically new, more robust, more capable file system than we've ever seen before.
The file system is really an exciting area of the system, in large part because you get so much out of it and don't even really know what you're getting. One of the things that we did with the file system in Mac OS X was we made it pluggable. What this means is that without Apple even being involved, other people can just put in new code to implement new file system types. Now, we've used that mechanism ourselves to implement a whole bunch of file systems that work out of the box, but third parties can do this as well for their own file systems, whatever they may want. Let me just give you some examples of what you can do out of the box with Mac OS X. On the local file system case, by local what I mean is those things that'll be on a disk or CD-ROM or DVD, something like that. We of course support the traditional Mac file systems, HFS and HFS Plus. But beyond that, out of the box, you get support for DOS FAT file systems. You get support for Unix file systems. You get support for the DVD UFS format, and you get support for all the popular ISO CD-ROM formats. Again, all out of the box, it just works. In the network case, you need to often connect up to servers, file servers, over some networking protocol, a networking file protocol. Again, out of the box, we have just superb support for what you can hook up to. Of course, we support AFP, the Apple filing protocol, out of the box as a standard native filing protocol. But even beyond that, we support NFS, which is very popular in Unix networks. We support SMB CIFS, which is the protocol used by Windows machines. And we also support a new standard called WebDAV, which is a file protocol based on the web's HTTP protocol. Now, we do all of this in terms of supporting all of these file systems in a way where no matter what file system you're using, you get the consistent Mac experience. Why is this important? This is important because in many instances, you may have your data on a file system, say on a Windows server, that's being shared with a Windows user. And you want to be able to have your data be on there in a way that you can interact with your Windows friends on that same server, yet you want to continue to get the great Mac experience. We've done it we've implemented it that way, and that's what you get. Similarly, because we use Unicode at the file system, and because the file system is thread safe, you get great features like full international support and great performance with multiple applications using file systems all at the same time. And finally, all of this is provided in the context of the kinds of security on the file system you would expect from a Unix-based system.
I told you we were going to get down to geeky level things. I wasn't kidding. Now, in addition, of course, to the file system, another key element of the core of the operating system is great networking support. With Mac OS X, we've built it on the most robust, powerful networking stack available. It's, in fact, the same stack that the Internet was invented on, which is the BSD TCP/IP stack. Now, like the file system that Avi talked about, networking is also pluggable, so we can extend it with many different network types as they progress in the future. Already out of the box, we include built-in support for all the major Ethernet formats, 10 base T, 100 base T, gigabit Ethernet. For 802.11 wireless networking, perfectly integrated, not added onto the system. PPP for dial-up, PPPoE for DSL and cable modem support, and legacy support for AppleTalk and infrared. And this is all, again, multi-threaded for maximum performance. And the last three features on the slide deliver one amazing benefit. The multi-link, multi-homing, and dynamic capability mean we can make for you this automatic network setting that's so cool. Out of the box, the networking set up to an automatic mode. So when you plug in your Ethernet, or you switch to airport, or you dial up on a modem, you don't have to change your settings anymore. It dynamically figures out the fastest way to get wherever you're trying to go and get you there. So at work, I can be on Ethernet, I unplug, and I'm on airport, yet I never have to change the setting again.
Okay, so we talked about a lot of technology there, and I guess it is kind of geeky stuff. I will admit that. Now, the problem with technology is it's no good unless you can make it useful. And what I like to observe is that we've packed all of this technology into an OS, but we haven't forgot about all the things you need to put around it that really make it nice and easy to use. What do I mean by that? What I mean is you get all this technology, yet at the end of the day, you get plug and play from your devices. So you get a FireWire device, a USB device to use them. All you do is you plug them in, they just work. What I mean is often when you're working on interesting technology, you can build up an architecture that makes things too slow. That is not the case, for example, in I/O, where while we've got a great architectural technology for how we do everything, we do not sacrifice and we get great throughput, both networking and with file system. You have to worry about issues like low latency. You know, if your machine isn't responsive, it doesn't do any good to have cool features because it's not responsive. And that's, when I talk about that, I talk about right down to interrupts and doing things at interrupt level very quickly. Those things are all considered and handled in Mac OS X. We have very low latency. Similarly, if you've got a PowerBook, and many of you do, and those of you that don't should go get one, you expect that when you close the lid, and open it back up, it wakes up really quickly. Well, actually, maybe you don't expect that, but you should expect it now because that's the kind of system that we want to deliver and that we do deliver. Similarly, you want to have great battery life when you're running your OS and your applications. We provide all those things in Mac OS X, and we do a lot of these things using object-oriented technologies, which are sort of the foundation for a lot of what we try to do, and will also allow developers to benefit from the work that we do as they bring their own technologies into the Mac.
So that's the core OS level and just some of it. We could go in much greater depth, but now let's pop up a level and talk about the media technologies. More direct benefit for a lot of you with the great media you can use inside of Mac OS X. This really sets a new standard in operating systems for the different types of media you can use and how well they are all integrated deep within the system. This is just a partial list of some of the media technologies that are important to all of us that Mac OS X excels at. 2D quartz, video and audio with QuickTime, 3D with OpenGL, a brand new audio architecture under the system, great new font level support with more font types than ever before, color sync integrated so the entire system, everything you see on the screen is color managed, image capture for cameras, and incredible device support.
Okay, so let's talk about the geeky aspects of this, and let's focus on Quartz. First of all, something to keep in mind is everything that relates to Quartz is based on PDF, and what that means is everything you do can be based on importing and exporting PDF and using PDF as a full-fledged data type. That means that any kind of application you write on Mac OS X can literally consume and produce PDF, a very, very powerful idea, which I think is going to have profound implications for applications on the Mac moving forward. Now, we build in some really wonderful technologies. For example, all the graphics you see on the screen are anti-aliased by Quartz. And we do it in a way such that not only does it look good, but it draws fast, again, without any compromises there. Fonts. We have support for a wide variety of fonts. If you've got fonts, you just drag them onto your system. They work, whether they're TrueType, Type 1, or OpenType. They're all supported. We love them all. Color sync. Phil mentioned color sync technology. It's integrated deeply into the system such that everything on your screen is managed by color sync, and it all looks great. Compositing. Compositing is a wonderful feature of Quartz that allows you to take different images, multiple images, in fact, not really just images, but graphics, whether it be PDF or other things, and combine them in very fun ways and very useful ways with transparency and lots of other effects to make truly stunning user interfaces. Similarly, if you sit down and use Mac OS X for a little while, something that you notice is it's a little bit different in terms of the smoothness of the way things operate. And what you notice is you never see anything flickering. You don't see buttons coming and going. You don't see windows that are half drawn or as they're being drawn. And that's because we use a technique called double buffering, where we draw things off screen first, and when the drawing is complete, we then push it onto the main screen in one fell swoop, so it looks like it's just one big operation. It really has a profound effect on the overall experience of using the computer. Also, at the window level, we have per pixel alpha and per window fade and morph. What does this mean? This means that for every window, you can specify at the pixel level what the alpha or transparency level of that part of the window is. So you can do some really incredible things with that. The other things that I mentioned all relate to the wonderful effects you see as the user interface is working itself, whether it be transparent windows, whether it be the Genie effect of windows shrinking down, or other things like that. Those are all primitives built into the Quartz graphic system that the Windows system and applications take advantage of. Now, as if that weren't enough, all of this is completely integrated into printing, which means that when you use Quartz to do your graphics in an application, your application basically automatically knows how to print because Quartz knows how to translate everything into something that can be printed very easily and with high quality, all automatically.
So one of the most important things out of the whole Quartz imaging model is PDF. So I'd like to just take 1 second to show you how the PDF built-in capabilities work for Mac applications. It's very simple but incredibly powerful. The most obvious example would be to take an application many of us love, Word for 10, a great new product, and I can create just beautiful, rich documents in Mac OS X. What if I want to send it to someone else to take a look at? What if I don't know what word processor they have? Maybe I don't know what fonts they have, but I want to make sure they can see this in a beautiful format using PDF, which, as you know, is a standard created by Adobe and is the most popular document standard on the internet. All I have to do in any application, and certainly any Office application, is go up to the print menu, and when you see the print dialog box, there is a button that says Preview. The system provides preview capabilities to all applications that print. When I click Preview, it launches the Preview app and automatically creates a multi-page PDF document of exactly what I had there in Word. And this is a real PDF. The fonts are actually bundled and included inside the document, so wherever it goes, whoever I give this to, whoever I send it to, gets a beautiful document to read exactly as I created it. So PDF works for all my applications.
Phil, you know, that's a word processor. Of course, it would work for that. What are you really getting at here?
What am I getting at? This is not something you just add to an application or the developer has to do a lot of work for. This is something that works on everything on macOS 10. So for example, I could take any application that prints and now create a PDF. So here's an example I thought of that'd be quite different and probably something you might not have thought of. Let's say I'm in the middle of a chess game. Let's launch the chess game that comes with macOS 10. Let me open up a game in progress. And here I am in the middle of a chess game, and I'm not sure what to do next. I actually know of a famous chess master who lives over in Half Moon Bay, and I want to email him this document and ask him for help. Well, sure enough, chess supports print. So I go to print, I say preview, and I've just created a PDF document of that chess game, mid-game, that I can send to him. He doesn't have to have a Mac. He doesn't have to have the chess application open. He can just simply look at this PDF document, see where I am, and respond to me. So anything that can print can create a PDF and can be shared with anyone in the world.
You know, I think this is a really profound feature of macOS 10 because PDFs can be put anywhere, and they're a great format just for saving things. And, you know, I think a great example is you stumble upon a great web page, just create a PDF of it. Just hit, you know, Command-P, print, review, and you've got a PDF of a web page you're looking at. You don't have to worry about the web page going away. You can send it to other people. All they need is a PDF viewer. They don't even have to be online to go to the website. So I just think it's one of those things. Most people don't even realize it's there. They kind of intellectually know it's there, but don't even realize some of the implications of this and the new kinds of workflows that can be created.
So next up is audio. We have an entirely new audio system built into macOS 10. It's one of the areas that our developers told us they really want us to work hard on to improve. And we've really gone and done the state-of-the-art audio architecture. We now have 32-bit resolution. This goes beyond the 24-bit that many pro applications are used to full 32-bit audio resolution. And it's real multi-channel. So you can add any number of channels to an application. You can do 5.1 surround sound, 10.2, things that others haven't even thought of doing yet. And yet it does it with low latency. And it's ultra low latency. You can get to sub-millisecond performance. We'll show you an example of that in a minute, what that really means, but it means incredible professional responsiveness in the audio system. And it uses Velocity Engine, that many elements of the core audio engine have accelerated for the Velocity Engine for super fast performance on GeForce systems. And we've done something our developers really asked us a lot for, which is to build in a real MIDI architecture with MIDI services. So now we have a true great MIDI engine that MIDI applications can be built on top of. And a lot of music applications use DSPs. So you can plug in and add effects, add synthesizers. Well, now we have a standard for that called audio units. And for DSP plugins that can be added to an application, if they're written to this new audio unit spec, they can be plugged into any music application, something that happens only on a Mac.
Okay, so I'd like to invite Doug Wyatt on up, who's going to help me out with a demo of all this. Hey, Doug, how you doing?
Good, how are you?
I'm doing great. Y'all ready?
Yep.
Okay, so Doug and I would like to show you some of the features of macOS 10, especially in the area of MIDI. So we've got a little app here that knows how to do a couple things. Let's go through it. First of all, one of the things that we can do now in macOS 10, just out of the box, is we can play MIDI. Right? Mm-hmm. So what we have here is a MIDI file, and let's just start playing this. This is music there's a very small description of it in the MIDI file, basically notes, and the computer itself is synthesizing all of this on the fly. So what you hear is being done by the computer. It's not a sound file, it's just MIDI. Okay, now let's stop that. Now, instead of taking data from the file, Doug, you can send the data to us from your keyboard, right? Why don't you do that for a second? So what's going on here now is Doug is playing on the keyboard. Why don't you explain what's going on here, Doug?
Okay, I'm triggering MIDI events from this keyboard. It's sending them over USB to the Macintosh. Through our MIDI architecture, we have drivers and application interface. This application is receiving MIDI events, and as soon as it receives a MIDI event, it's triggering, sending messages to the software synthesizer to render the notes.
And one of the key things here is not only does it work, which is kind of cool, but it does so with very low latency, so it feels like when you hit a key, you hear it, right?
It's extremely responsive, yeah.
Extremely responsive. If it wasn't, you wouldn't be able to play.
No, especially not fast music like I was just playing.
Right.
So.
Now, but to really show that and to show off some other features, what we're now going to do is we're going to play that MIDI file I just played, and then we're going to have Doug play along with it, which will show not only can we synthesize music, but we can have multiple inputs, put them all together on the computer. Again, the computer's synthesizing and combining everything, and then to validate that we truly have low latency, it'll hopefully sound good.
Yeah.
You're going to play well,
yeah.
right?
I'll do my best.
And that could only be the case if it was low latency, because if it wasn't low latency, he wouldn't quite know what was coming up. Or he would be playing based on what he hears, and it'd be too late by the time he
It's
heard
hard
it
to
and played it.
compensate for good latencies, yep.
Okay, so I'm going to start this up, and why don't you play along? Now, I think one of the really cool things that you can do is you can still use the computer. It's working really hard, synthesizing all this music, keeping up with really low latency, but I can launch an app like IE. There it is, just launched. I did massive amounts of disk IOs there to bring that up. It didn't cause any problem. Did you experience any latency?
No, it didn't feel anything.
Nothing at all? I can do something a little bit, you still got the app here. I can do something a little bit strange, but just to show that it works. I can also bring up a movie trailer. Now we got lots of networking going on, and we got more sound coming in. And it's all happening at once, all being mixed on the fly. Doesn't sound too good, so I'll stop this. And throughout the whole thing, did it still feel good? Still feels good?
I can still find my notes. I couldn't tell what they were, but
Okay. That's okay. It sounded okay to me. Thanks, Doug.
thank you.
Very cool. I put our engineers up against anyone else's engineers playing music. They are so good. We also mentioned device support is extremely important to this media layer and all the things you expect to be able to do. And macOS 10 has been built to be more modular and more capable than any other operating system, and certainly more so than macOS ever was. I won't list all this, but as you can see, we have built-in device support for all the major USB printers, more than just listed on the side. So you just plug them in, they work. All the major laser printers, you just connect to them on your network and they just work. You plug in all the major digital cameras and they work. DV camcorders, inside iMovie, whatever your application is, just work. All these storage devices, even the age-old floppy, all the way up to modern storage media like memory stick and smart media, just work with macOS 10. And input for devices like keyboards, mice, joysticks, speakers, and microphones all work built in with the device support and very modern architecture of device management in macOS 10. Another level we said we'd touch on today is security. Increasingly, this is becoming important to people who use personal computers to provide great security on their computer platform. As we've been building macOS 10, we've worked very hard to try to have great security at all levels of the OS.
Yeah, we take security very seriously, and it's ranked very high on our list of things to really get right. As a result, we've built a lot of technology into macOS 10 that relate to security, and we've done a lot of things with it that we believe help to increase the security of the system overall. So let me go through some of those points. First of all, authentication is built into the operating system and is required for those operations that may compromise the system in general. You need to validate that you're allowed to do these types of changes to the system before they're allowed to be made. Similarly, out of the box, we ship with a very conservative default setup in terms of all the settings that can be done to enable certain types of networking protocols, whatnot, to try to minimize a user from accidentally setting up an insecure configuration. Next, we build in a lot of technologies in their secure form. So for example, we ship SSH as the way to hook up via a remote terminal session. We ship SSL built in, and we ship in Kerberos built in for those people that want to use it. We also have technologies built in. This is a great one that most people don't even know about. There's an IP firewall built in to Mac OS X. You can get third-party user interfaces today, that will, third-party software that will provide a user interface to configuring the underlying firewall that's built into the operating system. We have a technology that we call Keychain, which helps you to manage your passwords and accounts, which is very useful for when you're dealing with multiple servers or things that require multiple authentications. And we have a really nice feature for ultimate data protection that we call encrypted disk images. This allows you to create a virtual disk on your hard drive that is completely encrypted, so that even if your system were compromised for some reason, someone still couldn't get your data because your data is actually encrypted. So getting the encrypted disk would do them no good. For people who want really secure environments, you can go all the way down to the level of setting a password on open firmware, which can prevent various operations that might be harmful to security, like booting off a CD, from actually occurring. You can just completely disable it and password protect it. And finally, as a foundation for all of this security, the concept of multiple users is built in and supported at the lowest levels of the system, so at all times the system knows what user is doing what and what they're allowed to do, and protects against bad things happening, including file permissions and other things like that. So let's ratchet really up a layer here and talk a little bit about Aqua, which is the face that you all see when you use Mac OS X.
I think many of you have seen this, and hopefully a lot of you are using Mac OS X, and you're now familiar with this great new user interface that we've brought to the Mac platform. It takes advantage of so many of the things that Avi mentioned earlier when we talked about Quartz. On-the-fly anti-aliasing, and drop shadows, and the Quartz compositing engine. So when you drag a menu over a QuickTime window, it's beautifully semi-transparent. They just interact beautifully and seamlessly, and it works the way you want it to. One of the most important things we thought about in designing the Aqua interface for Mac OS X is to make it not only friendly, but easy for new users to get into, easier than the Mac ever was. Yet, as professionals get deep into it and explore it, they find tools for them that make it more powerful than the Mac ever was. And that's a big challenge, to try to span from the new user to our most powerful professional creative customers. And we've done a lot of that work and achieved great results. And this is something others just don't try to take on. Now, one of the things we know about our customers, Mac customers, is that a lot of you really love to customize your system. You like to make it yours and set things up the way you like it. And many of the things in Mac OS 9 and previous versions that people like were actually tacked on and added and didn't work together really well. With Mac OS X, we worked very hard to make it more customizable, right built into the system, not tacked on.
Right, so there's actually quite a number of areas in Mac OS X where the user can just customize it to his or her heart's content. Let's go through some of those examples. First of all, toolbars. You see lots of toolbars throughout the system, certainly in the Finder, in the email program, and other places. In the Finder and other places, they're all customizable. You can put what you want in the toolbar and have it look any way you want. And many of them you can even, in fact, I think all of them, you can even hide the toolbar if you'd like to. The dock is a great area of customization where you can bring down things like folders or other documents and use menus to even get a custom environment, if you will, a custom way to go through your file system, for example. I'll show that a little bit later. System status menus, top right of the menu bar. A whole bunch of information that can appear in terms of system status up there, but it's all under your control. You get to control what's up there, where it is, and what it shows. The graphite appearance is a good example of a case where in certain situations, the colors that you see in the Aqua user interface aren't appropriate. You need to have an environment that doesn't have a lot of color in it or no color at all. We provided something that we call the graphite appearance with a simple checkbox. The color goes away and it looks more like graphite instead. One feature that I think is really useful that most people absolutely do not exist is the ability to do your own application and document binding. For any document on the system, you can instruct the system trivially as to how to open it in terms of what application to use. Similarly, one of the things that we've recently added to Mac OS X is something that we call full keyboard access. This has been something I know a lot of you have always wanted in the Mac. We have it now. It lets you navigate the Macintosh user interface without using the mouse. Finally, we have very powerful features for supporting multiple languages where you can customize to your heart's content Use whatever language you want, use whatever date formats you want, and use whatever number formats you want. So let's take a look at some of this. I'm going to give you just a brief overview of some of the ways that you can customize Mac OS X. Not too much, just a little bit. So let's start by looking at the Finder and the toolbar. Well, the first thing you see here is this is the default way we configure the toolbar, but by just selecting Customize Toolbar, we get access to a huge palette of other operations that the Finder knows how to do, and we can just drag them up to our heart's content, put them wherever we want, and we've now completely customized our toolbar. We can even revert easily back to the defaults if we'd like to. Maybe we want to take that one out. And we now have whatever kind of toolbar that we want. In fact, we can go beyond what's built into the Finder, and we can, for example, bring our folder up there and just leave it there. Now, let's say that we were somewhere else looking at the file system, and this was a project they were working on a lot, so we wanted to keep it in a place where we can get to it quickly. All we need to do, we just go click on it, bang, we're right there, just with a single click. In fact, you can do more. Let's say we have a document that we'd like to put in there. Just by dragging and dropping right on top of that icon, we'll end up doing a move or a copy depending on what you want to select. Simple as that. Now, let's say you don't want the toolbar at all on the Finder and you like the way the Mac OS 9 Finder works with the spatial representations of things and remembering where things are and what the size of things are. Simple. All we need to do is we hit this magic button right here. It hides the toolbar, and now we're operating in a mode that works basically like the Mac OS X Finder, where if we double click on something, we start getting into folders where we're just drilling down, just like we were before in Mac OS 9. In fact, we can move this around, and it'll remember exactly what we just did there, just like it did on Mac OS 9. Now, a really interesting, I'll say interesting because I don't know if it's good or bad, but an interesting way to navigate through the file system is to do what I've done down here, where I've got the actual icon for the drive down on the dock. Now, when you have a folder on the dock, you can use the dock menu to navigate through it. And when it's the drive, it means essentially you can navigate the whole drive. Watch this. If I click down here, I can literally navigate through the whole drive just by doing this. Okay, let me move on and let me show you the keyboard access feature that I showed. Not using the mouse. All I need to do is hit the magic key sequence, and I just activated keyboard access, and I activated the dock. Notice that it highlighted the Finder icon on the dock, and now I'll use the arrow keys just to go back and forth all through the keyboard. In fact, I can even use the up arrow key and start navigating through the dock menu, just like I did before, only now I'm using the keyboard instead of the mouse. Similarly, I can hit a different command key, and now I bring up navigation of the menus via the keyboard. So again, I'm using the arrow keys, and I'm just navigating right through the menus, no problem at all. So keyboard access. Let me show you one more thing which I find to be extremely useful, and that's the ability to control what application opens up which document. So here I've got a folder with a couple of files in it. These are both PDFs, and my system is set up to use Preview by default to open it up. Again, we talked about how PDF is just built into the OS. The Preview app can trivially just open up that data sheet, which is a PDF file, and render it. But let's say for some reason I want to open this document up with a different application. I just bring up the info panel, and I select the Open with Application, and it's telling me the Preview is set to open it. I can click right here, and it now gives me a list of all the applications that the system knows about that know how to open PDFs. So let's say I want to select Acrobat. I can even hit the Change All button, which will make this now the system default for PDF files. I don't want to do that right now, but I've changed that one file to be Acrobat. I go back here, just double click on it, and it opens up in Acrobat. And you can do that with any document in any application, just transparently. Okay.
So I just want to make a point on that last demo. I know for us at Apple, many of us use it quite a bit. It's incredibly powerful. And previously, you would have to go in with Tools and ResEdit and change creator types to decide who gets to open what document. And now you can do that right there from the Get Info panel. You have control over whatever application opens, whatever documents you want. You can make it a system-wide change, you can make it a per document change, and it will always remember that you even saw the icon update. Very, very powerful feature that I think very few users understand or take advantage of. Okay, now we're going to move up a bit and talk about the applications and the different ways of building applications on macOS 10 and how that will allow us to see just some great new software show up, things that were never possible before. As you may know, there are many different APIs for developers to take advantage of on macOS 10. There's a tremendous number of new apps here at the show, applications created first and foremost in Carbon. And Carbon is a great way to make a macOS 10 native app. Things that you see from Microsoft, from Adobe, and so many others are all done with Carbon, and that's a great way to make an application on macOS 10. What we want to take some time right now is talk to you a little bit about Cocoa, because it's new to macOS, and it creates yet another way to create a modern macOS 10 application and gives you some incredibly powerful tools.
Thank you. Yeah, Cocoa is very exciting. And let's talk about some of the technology that underlies Cocoa. First of all, something to keep in mind is that Cocoa is based on object-oriented technology with a dynamic runtime at the base of it. What does that mean? Well, for purposes of today, what it means is developers have at their disposal a powerful foundation of technology that lets them write their applications really quickly. This is enabled by the low-level plumbing of the environment, the fact that it's object-oriented and based on a dynamic runtime, but perhaps more importantly, because of the fact that we've already done a lot of the work, most of the work, for what most applications need to do. And that's in the form of foundation classes. These are the low-level classes that help an application manage memory, deal with Unicode, deal with text, things like that, or classes at a higher level that help to deal with the user interface. We often refer to it as AppKit, where if you want to have a menu, you don't have to write any code. You want to have a window? No code. It just all happens automatically because we've written that code in an object-oriented way where developers can just trivially take advantage of it. Now, with this kind of foundation technology, we've created a very broad range of coverage of the things in macOS 10 that you now suddenly get for free because they're supported by Cocoa. And so you get full Aqua as an application, for example. You get full access to AppleScript, and your app becomes automatically scriptable. You get full access to the underlying Quartz drawing. You get trivially the ability to use Unicode in everything you do, and all of this, whenever data goes in and out, is based on XML standards. Now, we've been so excited about the potential here that one of the things that we decided to do was to take our developer tools, which include a wonderful visual editor for building user interfaces, and we put them all for free with every copy of macOS 10.
So what I'd like to do, as a great example of a new Cocoa app, and one that a lot of customers have been downloading and getting excited about, is something from a great new Cocoa developer, Dan Wood from Corellia Software, and Dan has done something really marvelous with the power of Cocoa.
Come on up, Dan.
Thanks, Phil. Thanks, Avi. Okay, I'm Dan Wood of Corellia Software, and I've created a new application called Watson that I want to show you today. So we're all very familiar with the web, and we've all visited lots of websites, and we've probably searched for everything with Sherlock. But a lot of what's on the web is not really content, it's not really text, it's applications. But they're not really Mac applications, they're not Mac-like, going from page to page to page. So what Watson is a collection of the most useful web-based services, and you can see their icons along the top here. Except that rather than viewing them in their browser, it's wrapping these services up in an attractive Aqua experience. So we call it desktop web applications. And it combines the best of the macOS 10 user interface with these great services that are available out there on the web. And it's amazing how much it simplifies and speeds up your access to these kinds of services that you might really use on a daily basis. We're also pleased to announce version 1.1 of Watson today, and it includes 2 new tools, TV listings and package tracking. So let's just get into a demo. So the package tool accesses the tracking services of multiple carriers, of the most popular carriers, and basically at a glance you can take a look at the status on your packages that you have going on. So here we can see that these two guys were delivered, and I just ordered this yesterday. Aaron Hilligus has a great new Cocoa book, and they put it into the system just a few hours ago, actually, so I can watch this as it progresses its way to my house. In fact, we can add something new. I have a hypothetical air bill number here for a new iMac that I'm going to ship across country, and that's the UPS tracking number, so I'll add that to the list. And then as that gets put into the UPS's database, I can actually see how it's doing as it goes across the country. So another one we have here is the Movies tool. And the Movies tool is by far our most popular tool. So I have already pre-configured it in the settings drawer with a San Francisco zip code. And I really like the AMC 1000 on Van Ness because I have a great digital projector. And so we can say, okay, here's some information about the theater, and what's this movie, Monsters, Inc.? And you get to find out what the show times are. I see there's one at 1:20, so maybe if we all hurry, we can get there after this keynote. Anyhow, you can see a little bit of information about the movie, but what's really fun is that you also get to see a preview of the movie in QuickTime. There we go. And then you can also buy the tickets, and that'll launch off in your browser and do that whole thing. So finally, let's stop this movie. Let's try the Images tool. This does actually do some searching, some things that Sherlock can't do, so I thought what would be fun would be to look for Phil Schiller. No. So here's some images of Phil, and it just sort of fills this up dynamically. So there was this one interesting picture that I thought was kind of cool, and if you look down at the bottom here, the page, it's kind of fun, the URL says it's called Brush with Greatness. Watson integrates with other tools on your Mac OS X system, so in this case I can open this up with Preview, and that downloads the file and opens it up in Preview, and then you can save it and print it and all that kind of great stuff. So that's my demo. There's a few of the tools. We have a lot more on the way as well. So a lot of people have said that Watson is a really cool tool, and thank you. But I want to talk a little bit about what's under the hood, and I think that's pretty cool too. So Watson is written in Cocoa. It's a Mac OS X exclusively application. And I'm an old-time Mac programmer. I've been programming the Mac since the days of small black and white screens. And I've recently started using Cocoa. And I can easily say that using Cocoa has sped up the development process by a factor of at least 4. It's just amazing how well it's been for me. So this program, for instance, and all the tools that you see are about 20,000 lines of code, and the project was started in June with a development team of just 1 engineer. That's me. So what Cocoa gives you, you saw the list that Avi and Phil mentioned, but just for example, some of the toolbars that you see, or the columns view that you saw in the movie tool, and some of the low-lying things like XML support and the plugin mechanism and those kinds of things, mean that I don't have to spend my time writing that code and programming that kind of stuff. I can spend all my time working on what makes Watson Watson. And so, actually, the point is this. With Watson, if I hadn't been using Cocoa, it's that Cocoa didn't just make Watson easier to make and faster. It made it possible. Because if you're running on a limited budget, limited time, it may just not be feasible to use anything less sophisticated. So I couldn't have accomplished all this without using Cocoa. So check out Watson. It's on a Corellia.com website. You can search for it on Apple's Pages or Version Tracker. And it's just an example of what you can do with Cocoa. Thanks very much.
Thanks, Dan.
Well, in addition to the amazing things we're going to see brought onto Mac OS X with Carbon, and now great new things being built with Cocoa, we have some other environments too for some developers. You might have heard that there are a few people out there who happen to develop in Unix or Java. This opens it up to only like 500 million programmers who can now move on to the Mac. We have an amazing Unix-based operating system here. We have an incredible set of Java tools and capabilities.
So let's talk about the Unix part of the system. It's always interesting to talk to someone who's not really part of the Mac community, doesn't really quite know what Mac OS X is, but knows what Unix is, and is kind of wondering what this Mac OS 10 thing is because they've heard that it has something to do with Unix and it somehow has Unix type support. And so what you can do is you kind of sit down with them and you say, well, it just does all these things. It's what you would expect to be in any Unix-based system. So we start at the lowest levels with the mock BSD kernel, providing all the normal APIs, the POSIX level APIs that you would expect to a Unix programmer. You get a TCP IP stack there. That is the gold standard of TCP IP stacks in the industry. And then, you know, you talk to these people, again, they're Unix people, they expect certain things, and you say, well, you know, the standard system libraries that you're used to, they're there. The normal system daemons that are there that do networking and other things, they're pretty much there. The commands from the BSD world and the GNU world, they're all pretty much there. You know, things like awk, grep, vi, emacs, perl, gcc, ssh, they're all there. How many out there know what all those are? That's pretty good. That's pretty good. But it's all there. And the other thing is, for the occasional thing that's not there, it's almost trivial to just put it there because you grab the source code, which is generally freely available on the net, and you compile it and you build it, and it's done. So it's really powerful. And the answer is always, yeah, it's just there.
So we're going to see some great things from Unix developers coming onto the Mac. You've heard of big things like Maya, which came over from the Unix world, but there's probably some great things you haven't seen yet. And this demo, I think, is just really amazing and wonderful to watch. So I'm really happy to have Chris Horvath here from Tweak Films. Chris?
Hi, everybody. Today I'd like to talk to you a little bit about creating visual effects for feature films using some of the tools in OS 10. Most movies that you go to see today have visual effects in them of some kind. Some of those effects are really fantastical, like dinosaurs, and other of those effects are taken from the real world, such as the ocean waves in The Perfect Storm. Doing realistic-looking natural phenomenon like smoke, fire, cloth, and especially water is really difficult. It involves a lot of physics, a lot of math, and it uses a lot of really heavy numerical computation. And traditionally, these kinds of computations have been almost wholly done in Unix-based systems, big multiprocessor machines. So as a visual effects artist, I've worked primarily with water and other types of physical simulations. I've had to be a Unix programmer, and I have been a Unix programmer for about the last 8 years. I've worked on things like Deep Impact and The Perfect Storm. And for the last 3 months, I'm surprised to say, and it's still a little bit weird, that I'm also a Mac programmer, and OS 10 is the reason why. What I'd like to show you today, what we brought with us, is a water and ocean wave simulation that my company, Tweak Films, built. And we originally built this as a Unix application. And about a week ago today, I got a call from Apple saying, can you guys port this to OS 10? And we laughed. But I figured I'd give it a try. I worked a little bit with OS 10, and I was surprised that not only were we able to port it really quickly, but in fact we were able to add a whole bunch of features that would not have been possible in any other system, certainly not in our Unix-based system. And I'd like to show you that now. So, launch this up. So what you're seeing here is a numerical simulation of deep ocean waves. This is actually simulating the physics and the movement of these waves in real time on this computer. It's displaying it to the screen in 3D using OpenGL. And so one of the things I can do is, because it's in 3D, I can change my viewpoint, look at it from different angles, rotate around it, I can zoom in and out. So this is not something that's playing back like a QuickTime movie, and it's not something that's a pre-recorded animation. It's actually computing these physics and drawing it in real time. So because it's computing the physics, I can pull up some behavioral parameters, and these let me change the way the water actually behaves. So as a visual effects artist, I can use this to sort of sculpt the water to do what I want it to do in whatever scene I'm working on. So I've exposed a few controls here. I can change, for example, the direction that the wind is moving in. I can change the height of the waves, make big scary waves, or more, realistic, tranquil waves. I can change the size, the wavelength of the waves. So if you get them really small, these are like swimming pool waves, and these are more like big, deep ocean waves, moving really slowly. I can change the resolution of the simulation, so I can make a nice, smooth wave that has relatively little detail, all the way up to increasing levels of detail up to a huge amount of detail. Again, simulating in real time. So this right here is about where our Unix tool for doing this stuff stopped. And in fact, one thing I wanted to say was that our Unix version of this tool did not run nearly as fast as this. When we brought it over, it is also optimized for the AltiVec, which is the velocity engine in the G4, and this thing just screams. So already bringing this over to the Mac has given us some advantages and really a lot of ability to play around with it, but the Macintosh also has, this machine in particular has this NVIDIA GeForce 3 card in it. It's tons of graphics power. So previously, in order to make this into a pretty picture that actually looked like a finished product, we'd have to save this out and bring it into another tool like Maya, for example. But using the graphics capabilities of this machine, I thought I'd see if I could turn this into some realistic working water right here in this application. So the first thing I'm going to add to make it look more realistic is a reflection, because water reflects. What you see right here is moving like water should move, but it looks more like gray milk than like water. So first thing I'll do is use a QuickTime VR file to provide me a three-dimensional reflection map. So right away, it starts to look a lot more like real water. And this is the first time I've ever been able to see something like this and interact with it at this scale. So I changed it around a little bit. I'm going to make the reflections at the top of the waves stronger and make the reflections in the troughs a little bit smaller. And as soon as I got this working, I immediately became megalomaniacal and started thinking I was Lord of the Waves. And so I'm playing around with this, and just completely serendipitously as that happened, Clash of the Titans came on. And there's this great scene where Zeus is playing with the fates of mortals in his little pantheon. I thought, well, wouldn't it be cool if Poseidon had kind of, he could go and control the ocean from maybe his little marble bowl. So I opened up Maya and built a little marble bowl and found a Mount Olympus environment. And yeah, so Lord of the Waves. So that's what I wanted to leave you guys with today. And this application we're going to add a few more features to it so you can play around with it and save off files and render images, and it'll be freely available from our website at the end of the show, the end of this week. So that's tweakfilms.com, and thank you very much.
Thanks, Chris. That is so cool. Just amazing what was done. And to think he started that just a week ago. Amazing power. We mentioned Java. As well as having great Unix, there's a great Java system built into Mac OS X. In fact, as many of you know, it's the only mainstream operating system that ships with Java 2 support. Java 2, of course, thanks to wonderful Sun Marketing, is also called JDK v1.3. I don't know how they came to that numbering, but that's what it is. And we didn't stop at just building in the most up-to-date Java. We made sure it had the fastest VM, Hotspots VM from Sun. We made sure it had the Java 2D support, printing support, drag and drop, the ability with the swing tools to create user interfaces, and of course, most important, the ability to put an Aqua interface on your cross-platform Java apps. So people can have Java apps that run on Unix and Windows and on Mac OS X, only they'll look better on Mac OS X as they take advantage of Java. And then, of course, they can take advantage of things outside of Java as well on the Mac platform. QuickTime as a way to work with Java and provide QuickTime content inside Java. And that's been one area where it's been lacking, is a true powerful media layer, and Apple provides that with QuickTime. And if you want an industrial strength tool to build client-server Java apps, we have that with WebObjects 5. It's a really strong Java story on Mac OS X.
And so if that's not enough, there's more. We've talked about Java, we've talked about Unix, we've talked about Cocoa, we've talked about Carbon. There's all these different ways to build applications to just access the whole world of stuff out there. There's another one which is hugely strategic to us, and that's AppleScript, which is built in right at the bottom of Mac OS X, where every application can take advantage of it. And we've done a lot of work to integrate it really well, and we've made some really good progress lately that we'd like to tell you about.
And as you know, AppleScript is incredibly popular with our professional customers. They create scripts in the Finder to automate tasks in macOS. They've created scripts to automate their workflow between applications because it can control AppleScript-aware applications. And that's made it critical to so many of our professional customers. And they wondered, in macOS 10, we're going to be committed to it. Would we really do the same thing? Well, in macOS 10, customers are learning not only have we been committed to it, we've gone far beyond anything ever dreamed of in macOS before. And just this past month, in December, we shipped this amazing new tool we call the AppleScript Studio. And the AppleScript Studio is this wonderful thing that allows you to now use AppleScript to create professional, high-quality, rich applications. It uses the same tools you use to create Cocoa applications, Project Builder for professional development, Interface Builder for creating very rich macOS Aqua interfaces to your applications. And so it gets everything from Cocoa and Aqua for free inside your applications. The graphic widgets, all the great quartz effects, great text capabilities, all built in now to your AppleScript rich applications. And in addition, AppleScript adds the ability to talk to internet services, data like what you saw with Watson. So with AppleScript, you can use XML and SOAP, the latest standards for talking to data services on the internet. And this is so great, we'd like to invite up Sal Segoyan, our AppleScript product manager, to give you a demo.
Thanks, Bill. Thanks, Avi. Welcome this afternoon. AppleScript, as you know, is Apple's incredible automation technology that for the last decade has enabled our customers and our users to make incredible solutions to make their lives more productive and easier on the Macintosh. And the good news is that on macOS 10, it's gotten many, many, many times better. And today we're going to show you one little aspect of that, and it's about writing scripts and writing script applications. Since 1992, the way that you wrote a script on macOS was using the script editor application that I just launched. As you can see, it has a very simple feature set. There's no special buttons up here. It doesn't do fine change. There's no interface. You can write scripts with it and save those scripts and run them. And since 1992, that's what's been available to you. With macOS 10, as Phil had mentioned, we've taken AppleScript and made it a peer language with Objective-C and Java. And what that means is now we can take AppleScript and use the same development tools, Project Builder and Interface Builder, that Objective-C and Java use on macOS 10, and we can create the same macOS 10 native applications. So let me show you the Project Builder environment. This is AppleScript Studio in Project Builder. There's a lot to look at here because this is a professional development environment. It's not something simple like the script editor, which is the simple text of script editors. On the right-hand side, I have my script open, and you can see there's the various routines and the colorization that happens. On the left-hand side, I have the various assets that I use in creating my macOS 10 AppleScript application. I have the script there, I have various images that I'm using, I have various templates from InDesign that I'm using, and other resources can be listed in this window. I can also do things like check my dictionary of the application if I want to find out something about what particular commands are available to me. That all appears in the same window on the right-hand side. And I can go back to my script, I can go into a debug mode, and since we're in Project Builder, since we're in a professional environment, we can now do step-by-step debugging with our scripts. So we no longer have to do things like bring up dialogues to find out what's going wrong in our workflow. And this kind of tool enables us to make incredible macOS 10 applications. Let me show you one that I created. This is called Ad Builder. It's a small macOS 10 application that I created for making a real estate catalog. As you can see, it has all the Aqua elements of any macOS 10 application. It has the beautiful Aqua look. We have tabs. We have radio buttons. We have pop-down menus. All the things that are available to any Aqua application, we also have here in AppleScript Studio. So I'm going to use this application to create a real estate catalog using Adobe InDesign, FileMaker Pro, and iView Media Pro running on macOS 10. So let me choose my template style. I think I'll go with the outside one. I like that. I'll pick an area of the country. I'll pick Piedmont and a realtor that I'd like to feature. And I'm going to choose to import text and graphics as well. I'll click the Build Document button. And when I do that, the scripts inside of this application start working. It opens up a template that's in the application itself, gets the information from FileMaker Pro, brings it into the appropriate boxes, and sizes and scales it for it automatically. Then it goes to the images, brings in, and one at a time, bring it in size and scale. This is only possible on Mac OS X with AppleScript. Thank you. And AppleScript Studio is free. It comes with our developer tools and it ships in every Macintosh. So thank you.
Thank you, Sal.
Thanks, Sal.
Sal is king of the demo at Apple. He is so great. Well, we're just about out of time. We have one last thing we wanted to do. Before we ended, we thought, there's so many great applications, over 2,500 applications. And there are many that you hear about every day. And here at the show, you hear about the things Adobe's doing that are so great. You hear about the things Microsoft is doing. You might even have caught in the announcement here at the show what Sybase is doing. The Sybase guys are bringing industrial databases to Mac OS X, something we've never had in the platform. Yes. So there's so many big things happening, and I'm sure you're watching and learning about all of that. But there are also so many smaller things from small companies, from cool tools that you can't live without, or you wish you had and you never knew was on the platform. And there are many of those in the 2,500 as well. So I want to take just a few minutes to quickly click on and show you a couple of all these hidden gems that you can find all over the place for Mac OS X, and some of you may not have known were here. So if we could bring up this Mac. This is very cool. I have a Mac here, and I asked the team to quickly throw on just shy of 100 applications on the dock. So if you ever wanted to, can you expand the dock and have over 100 applications? You sure can. There's a lot here in the dock. And so, yeah, if you have just a few minutes, what I'd like to do is click on each one of them and launch them all. No.
Phil, I think the answer is no, we don't know what the limit is. We haven't got there.
We do not. Someday we'll have a dock fest, and we'll see how many we can dump in there. But this is where, by the way, magnification really works. I've got approximately 100 docs here, applications. They're not in any particular order, and I'm just going to go in and find the ones I want to demo. The team purposely did not put them in any order. So the first one I want to do is called Earth Browser, and here it is. Earth Browser, cool thing you can download on the web. Maybe you didn't know it, but you can find the time, the weather in many places around the world in real time with the Earth Browser. It's very cool. We can just zoom around, see where it's day, where it's night. You can click on, Honolulu. Let's get the weather in Honolulu. Very cool. It's a lot nicer than it is here. A little cloudy, but still better.
Phil, can you show us the South Pole?
Oh, okay. There's the South Pole. There's a camera here, so if we click on it, we can get a picture from the South Pole. Very cool. So in case you ever wanted to be there. So anyway, Earth Browser, one of the many cool hidden gems available if you just surf around on the web. Now let's find another one. Let's go a little more educational. Maybe you're a chemistry student, and many of us have been there, had to work through our big chemistry books, lug around these 10-pound books just to look up things on the periodic table. Well, now we have incredible choices for education for software like this periodic table software from Synergy. Let's bring up a basic table. And maybe you're wondering, you have a titanium PowerBook, and you're wondering, what is the melting point of titanium? So let's just click on it, and sure enough, 1,943 degrees Kelvin. So if you're ever wondering how close to the sun you can get with your titanium PowerBook, on the Mac you have the tools to do that. Amazing hidden gems. So just one of the things you probably haven't heard about, but you can find out there in the web. Now since we're getting kind of techie, let me get really techie on you. Let me go find Atom in a Box. Now, you probably have always wanted to see the orbitals in a hydrogen atom. On Mac OS X, somebody's created an application just for that. Here we are looking. Let's get inside it. Let me bring it up in some color. Bring those phases in color. Very, very cool. Let's play with the spectrum a bit. You can actually hear the humming of these orbitals. That is not the sound system playing games. And we can actually control it in three-dimensional space. So I don't know about you, but I have always wanted to find out what the orbitals look like on a hydrogen atom. Very cool stuff, hidden gems all over the web, stuff that shows the diversity of programming and applications going on Mac OS X.
Well, and if you can do that on Mac OS X, I'm sure it can do anything anyone in the audience needs.
Well, I'm sure if you're like me, you like to play games. I like to play games. I do it too much. And here's one I downloaded just the other day and got it on the internet. It's very, very cool. Demos Rising from Ambrosia Software. And it's a new version of something familiar to some of us who have played in arcades before. And it looks incredible on Mac OS X. Here I am in a spaceship flying over Mars in a valley in a hypothetical view of Mars. And I'll tell you, this is, I've never played it, but I've managed to get good at it. This is very, very cool. Well, here's some guns to take care of.
Hey, Phil?
What?
I think they might be getting hungry.
Can I just finish this level? All right.
Do I let them finish?
Okay. No, that's all right. We'll get a two-player game going later. Okay, now just to balance it back with the amazing, with fun, here's one that I saw recently that just blew me away. I don't know about you, my background is actually in biotech. That's where I went to school and learned about things. And here is an amazing product for seeing a protein sequence. Some of the new emerging stuff happening in biotech. It's by a company called Genentech. And we are looking at a protein sequence in 3D space. We can control it, move around in it. It has great internet connections for finding out things. We can look at the amino acid sequences on it and highlight them. It's just incredibly powerful. Now, I know some of you are cringing because you recognize this sequence. For those who don't, it's a toxin from a python. So that's what we're looking at here in 3D space. But the amazing stuff that people are doing on Mac OS X, you just go out there and find that on the web. Very cool. So last, I'll bring up something that you've probably may not have seen on the web, but I think it's something that everyone would love to have, which is the ability in the dock to get access to news headlines just by clicking a button. There's a really cool product called Mac Reporter, and it uses those dock menus that Avi showed us earlier. And so you don't have to run the app, you just click on it in the dock, and you set up in your preferences what news services you want to hear from. And you just set whichever ones you want, and then when you click on it, it pops up and you pick that news service and you get instantly the online headlines and you can jump to any story you want. So here's a wide variety. We can go from CNN to find out the news of the world to Mac Central to find out the news of the show here today. All right there using dock menus on the dock. So those are just a few examples of some of the hundreds and thousands of amazing applications and gems you can find on the web today and at the show today from Mac OS X. And again, there's 2,500 applications, so many of them. You can just search on the Mac OS X page on Apple's website, go up to a lot of other great places, Mac Central Version Tracker. Last quarter, we had over 1,000 applications come out for Mac OS X. That's over 10 a day, over 10 a day. So there's more out there than you could ever imagine.
Right, so we obviously couldn't demo them all for you here today, although we'd certainly love to. What we thought we'd do instead is leave you with a different kind of a demo of all of these applications. What we did was we listed them all in our PowerPoint presentation, and we set up PowerPoint to do transitions from one to the next as fast as it could. The good news is they're all in there. The bad news is we estimate it takes about an hour to go through the whole thing. So Phil and I are going to leave, but if any of you would like to stick around, feel free to watch the whole list. Thank you.
Thank you very much.